All right. Hi there, class. I thought it might be helpful if I modeled the process for graphing some of the trig functions with multiple transformations. So I hope you find this helpful. And here we go. All right, so this is the sine and cosine hard question from class, and I'm going to walk you through the process I would use if I needed to graph this function. So the first thing that I'm going to look at is I'm going to look at this negative sign, and I'm going to write a little reminder to myself that I need to reflect. So this is going to be the reflection or vertical reflection over the x-axis of a cosine graph. Then I'm noticing the 1/2. That means the amplitude is a 1/2. I'm also noticing that there is no vertical shift, which means my sinusoidal axis is going to stay at y equals 0. So now right off the bat, I know that instead of my maximum of cosine being 1, it's going to be 1/2, and instead of my minimum being -1, it's going to be -1/2. So I'm going to start with that. Then I've got some horizontal transformations. First of all, I need to factor out this 3 so that I can isolate the horizontal shift from the adjustment to my period. So I divide 3x by 3 and I get x, and I divide 3 pi by 3 and I get pi. So now I'm looking at a b value of 3 and a phase shift or horizontal shift of pi. That means my period, instead of being 2 pi, is now 2 pi divided by 3. So everything's been horizontally shrunk. And then my phase shift, I am moving to the right pi units. So first of all, what that means is instead of starting my graph at x being 0, I'm going to start when x is pi. And so I can treat my 0 of my cosine function as pi. And then if I want to go forward one period, well, now I need to add 2 pi over 3. So I'm going to think of pi as being 3 pi over 3. And if I add 2 pi over 3, now I'm at 5 pi over 3. So that means my first period is going to end at 5 pi over 3. And then halfway between, well, halfway between 3 pi over 3 and 5 pi over 3 is 4 pi over 3. And then I also want to divide each of those in half. So now I'm going to think of sixths. So I'm going to think of 3 pi over 3 as being 6 pi over 6. And I'm going to think of 4 pi over 3 as being 8 pi over 6. And that means halfway between is going to be 7 pi over 6. And then halfway between 8 pi over 6 and this is 10 pi over 6 is 9 pi over 6, which is really just 3 pi over 2. So now I've got the starting point and ending point for the period, the first period that I'm going to graph of my cosine function. Remember, I'm treating this pi as my typical 0 because it's shifted to the right from 0 to pi. So normally cosine at 0 would start at its maximum, so it would be starting up here, and then I'm shifting it to the right, but now I'm reflecting, so I'm actually going to start at my minimum. And then cosine goes to the middle, then it's going to go to its other extreme, in this case a maximum because it's reflected, then back to the middle, and then back to where it started. And this is one period of this new cosine function. It's got an amplitude of 1/2, it's been reflected, the period has been adjusted so that it's 2 pi over 3, and it's been moved to the right pi units. If I want to duplicate this period, go through the same steps. From 5 pi over 3 plus 2 pi over 3 is 7 pi over 3. Halfway between is 6 pi over 3, which is really just 2 pi. And now I'm going to go to sixths. I'm going from 10 pi over 6 to 12 pi over 6. So halfway between is 11 pi over 6. And then from 12 pi over 6 to 14 pi over 6. So halfway in between is 11 pi over 6. And now I can just duplicate my graph from the bottom to the middle, to the top, to the middle, to the bottom. And now I've graphed two periods. hopefully this gives you a sense of the steps that I would use, and that will help you as you're practicing these on your own. Keep working, keep practicing, and we can figure this out. I promise you.